Okay, each roundup I try to do at least one programming talk and one non-programming talk. This one is a non-programming talk, so I'm only going to use math and physics and computer software. We humans perceive audible frequencies somewhat like a spiral staircase. Doubling the frequency makes one turn up the stairs. In a sense, you're back to where you started, but one floor higher. In music, that's called an octave. Okay. The remainder of this talk will ignore the floor level and look straight down the spiral staircase shaft. Ignoring powers of 2 in the frequency just means that all octaves are considered equivalent. Definite pitches can come from vibrating columns of air or from a vibrating string. All else equal, reducing the length of the vibrating entity increases the frequency proportionally. Cutting the length in half doubles the frequency. The vibration can be forced to occur at integral multiples of the fundamental frequency. These multiples are called harmonics. A string player can lightly touch the string without pressing it to the fingerboard. A brass player can use breath and lip pressure. Here are harmonics 1 through 16 of an arbitrary fundamental tone. Some instruments, such as the bugle, can only play harmonics. Familiar bugle calls are made up of only the 3rd through the 6th harmonics. Okay, this plot shows the harmonics around the spiral staircase. Because we're ignoring factors of 2, notice that 1, 2, and 4 are in the same position as are 3 and 6. Because a wind instrument can feasibly play only a few harmonics, there's a limit to the range and variety available. This is true even when you play 2 identical instruments together. We can get more musical variety by constructing another instrument whose fundamental frequency is a non-octave harmonic of our first instrument. Let's add a second instrument, 2/3 the length, with a fundamental frequency 1.5 times the first. Notice this simply rotates our pattern so that 1, the green fundamental, is located at 3 of the original white group. We can also go the other way and build an instrument that's 3/4 the length of the first, with a frequency 1 1/3 times the first one. Notice this simply rotates our pattern in the other direction, so that 1 of the white group is located at 3 of the new red group. When we put these notes in order together, here's what we get. The major scale of Western music. Instruments like the harpsichord and piano can tune each of their notes individually so we can decide how to break up the octave. If we break the octave up into 12 units, that minimizes the error of trying to match the harmonics of the original instruments. So, as a result, that's why there are 12 steps in this other staircase.